So for number 3, we should have x times x, x times negative 2, right? And then we have x times 1, and 1 times negative 2. And then we can combine the two middle, negative x and positive 1, still be negative x. And we'll keep the x squared the same, keep the minus 2 the same. Right. Likewise, we could also just use the box and multiply these out. Okay. Get v squared plus v plus 3v and plus 3. Don't forget to combine the diagonal here. So we have v squared. 3 plus 1 is 4. And bring down the 3. So think about this, how to reverse all this. Now, let you know ahead of time, you can do either method when you're reversing. Right? Doesn't matter. Okay. But what happens? How would you go if I just gave you this only? How would you go backwards and get this? Right? How would you go from, like, this doesn't change, the x squareds don't change, the negative 2's don't change. The only thing that changes would be you would have to rewrite the minus x as negative 2 plus 1. How could you do that? Right? Also, you have to figure out, well, when you're multiplying these two have to multiply to whatever you get right here. Right? So we have two things going on. We have two numbers that multiply, two numbers that add right here, but we also have the same two numbers that are multiplying to this number. So if we're going to reverse that, we need to figure out the right numbers for this to work. So again, what two numbers would multiply to 45? Right? You need two numbers to multiply to 45. Right, we're going to have x here and x here, but whatever two numbers we put here, they're going to have to multiply to positive 45. So what are two numbers that multiply to 45? 9 and 5, okay. But because of this right here in the middle, we know they also have to add to negative 14. So the same two numbers have to add to negative 14. And you see how I'm kind of creating this x here. So it's a good way of writing it out when you're trying to figure these out. You need to find two numbers that multiply to 45, but add to negative 14. And a lot of you said 9 and 5, which is close, but they don't add to negative 14. What can I do to change this to make it work? Yeah, make them both negative. So if negative 5 and negative 9, those do add to negative 14, and they multiply to positive 45. So now I can reverse this. I can go back and replace the middle term, the negative 14, and replace that with the minus 9x and the minus 5x. So that was the first step. I'm just trying to do this whole thing in reverse. I have three terms, and I replace that middle term, which usually comes from adding two things together, and I'm trying to break it apart instead. Okay. And now, how do we get these four terms to begin with? We multiplied, right, x times x, x times negative 2, and then we multiplied again 1 times x, 1 times negative 2. So we need to reverse that. We actually need to take a number out. We need to take something out. Instead of multiplying in, we got to remove it, right? We have to go in the reverse direction on both of it. We have to take something out of here and the same thing out from here. Kind of like we're putting x into both of them. We're multiplying by x into both of them. We have to take something out of both of them. And that's what factoring is. So looking at the first two here, what can I take out of both of these? What do they both have in common? What can I remove? The same thing from both of those. So looking at both these, what do they both have? They both have an x. Right? They both have an x. And if I was to remove an x from each one of these, what would be left over inside the parentheses? Well, there'd be an x, because x times x is x squared. If I took x away from here, I would have a negative 9. So you see how it's the reverse of multiplying. That's what factoring is. You're taking the same term out from both, as opposed to multiplying them both in. And same idea here. What do both of these terms, here and here, what do they both have in common? What goes into both of them? Yeah. 5 goes into 5, 5 goes into 45, so you can take a 5 out. Notice I took a negative as well, just because it's negative in the front. So what happens if you take a negative 5 from this first term? What happens if you take the negative 5x and you take out the negative 5? Just left with x. So reverse what we're doing, right? We're taking something out. What about 45? Negative 5 times what was going to equal 45? Negative 9. So we just took out a negative 5 from here, and we're left with just x. And we took out a negative 5 from here, which leaves us with a negative 9. If you're not sure about that way, just ask yourself, negative 5 times what is negative 5x? X. Negative 5 times what is positive 45? Negative 9. You're just doing the reverse direction of everything. Okay? And then how do we get our two answers? So you can see that two of them come out to be the same. Right? So that's going to be one of your answers. And then lastly, you have the two other parts, and that's your other answer. So that's how we just did the whole process in reverse. Okay? Now, if you want to check your work, you can always multiply it back together. So we can go through here and do x times x, do x times negative 5, do negative 5 times 9, and do negative 9 times negative 5, and you'll see the exact same work, right? It's the exact same work, and when you multiply or add the middles together, you get negative 14x plus 45. So it's the same thing we started with, right? We're just doing the whole process in reverse. The nice thing is, once you get down to your answer at the end, you can always check it really fast and see if you get what you started with. And if so, then you've done it right. Now, this is kind of weird because we haven't done this in reverse for a while. And for a while, you're going to be thinking, I'm just doing everything in reverse. But after a while, you'll kind of get the hang of it, and you'll see it's as its own thing. You know, when you first learned subtraction, it was really weird because you've only been adding up to the point. And then you thought, well, I'm just doing the reverse of adding. But after a while, you just called it take away. You just called it subtracting, minus. Same thing here. You're going to think of this as weird because we're doing this thing backwards. But after a while, you're just going to call this on factoring. Okay, so one direction is called multiplying together, multiplying, find the product. But to reverse that position and go back to where you started, that's called factoring. And it's the same steps, it's just in reverse, right? Same steps, but in reverse. Okay. So let's practice on another one. Go down to number 7. Okay, a lot of little things, I know. So, but know that our goal, right? Our goal is to get down to here and have 2 parentheses. And because it multiplies to b squared, I know both of these are b's. And I just need to figure out what the right numbers are supposed to be here. Remember, these are x-intercepts when you're graphing. That's why we're doing all this. We know the y-intercept, if we graph this, would be positive 24. But, you know, if all I have is, well, I know the y-intercept is 24. That's way up here. That's kind of hard to graph. We need to do this because we need to know, well, where are the x-intercepts? Are they here and here? Okay, then maybe the vertex is right here. And then because of symmetry, I can go across. Okay, now I can graph the whole thing, right? But just alone in standard form, you only have one point, which you can't do a whole lot with. And that's why we have to go through and do this, trying to figure out x-intercepts. So let's not forget what these numbers actually mean as we're doing this. All right, so we need two numbers, right, that multiply, right? No matter what two numbers I get right here, they have to multiply to 24. So they have to multiply to 24. But they also need to add to the middle number here, 11. So what are the two numbers that multiply to 24 and add to 11? We get here 8 and 3. Right? So we got, instead of writing 11b, we're going to write 8b plus 3b. Right? We're replacing. Usually we're adding that together and getting our final answer, but now we're going reverse, so we're breaking it apart. Right? And now we have to do the distributive property in reverse. So when we're multiplying, recall, we have to do the distributive property 1, 2, right? Once there, and then we have to do it again on the bottom. So now we have to do this part, but in reverse. We're taking a number out. The same number or variable we have to take out from both of them. So let's reverse this. What can you remove from b squared and 8b? What do they have in common? What's the same? You say, oh yeah, they both have a b. So let's take a b out of each of those. So we have a b, take it out. What are you left with inside? Well, we got a b left over. Took one of the b's out. There's one left inside. If we remove the b from here, what do you have left over? 8. Yeah. And of course, you can always check it. If you're not sure about that, just say, well, does this times this equal that? Yeah, b squared. Does this times this equal 8b? Yeah, so you've done it right. So for a while, you're going to be like, I got to check it just to make sure I'm doing it right. But then eventually, you'll just get the hang of it, and it'll be natural. And same thing here. Look at the second one. We got to do two of them. What can we remove from 3b and 24? What do they have in common? What goes into both of them evenly? 8 doesn't go into 3. 3, yeah. 3 goes into both of them, right? And then what's left over? Well, 3 times what is 3b? B. 3 times what is 24? 8. There we go. Now you might have noticed on both of these, when you're doing this, you see how they come out to the same thing? These are both x minus 9s, and these are both b plus 8s. If that happens, you've done it right. If it doesn't happen, something's wrong. So you kind of have a check within the middle of the problem. If you get to this point and you have the same in both of them, you're good. That means you've done it correctly. So we have one of our answers will be b plus 8. Okay, will be the same as what's inside here. And the other one is the b plus 3. So now, eventually, you're not doing this on tonight's homework, but I could look at this and say, oh, you know what? The x-intercepts, those are going to be -3 and -8. So it's actually over here, -3 and -8. I could figure out the axis of symmetry, which is right in the middle of those two, right? That would be 6.5 negative. No, 5.5 negative, right? That's the middle. And then I could also plug in -5.5 into here and find out, oh, it's probably right here. And then I could use my axis of symmetry, which is down the middle. And since I have 24 over here, I would have 24 over here. And then I could graph my parabola. And that's where we're heading eventually by Friday. But today, we're just practicing going from standard form, which has the y-intercept, to factored form that has the two x-intercepts. We're just reversing it. Okay? All right, so that can be a little overwhelming. But remember, we have more than one method. We also have the box method. So some people like the box method. Let me do 6 and 8 using the box method and see if you like it better or maybe not, and just to tell. So let's look at these two. Now remember, our answer is going to be this, right? That's our answer, v plus 1 and v plus 3. So I'm going to fill in the middle of the box and work backwards to get the outside. It's everything in reverse. I still need to figure out how to break it up into two parts because I only have 3 terms, right? So I still got to do the same x and figure out what multiplies to this and adds this, but it works pretty well. So let's watch this. I'm going to set this up, And the nice thing about this, whenever you get stuck and you're not sure, look at how you do the other direction. Like, where do I put the r squared? If you look at this, like, oh yeah, that's usually right here. So I know the r squared goes right there. Where should I put, the 3? The 3 is usually the number on the end. So if I have a 20 on the end, I know that goes into the bottom right corner. I still need to figure out, well, what multiplies to 20 and what adds to 12. And what are those two numbers? It multiplies to 20 and adds to 12. 2 and 10. All right, so we have, or 10 and 2. The order does not matter on this, by the way. On either method, you could put 10r here or 2r here. It does not matter. Order is not important. All right, and now I'm pretty much doing, at this point, the same thing I did right here. I'm pulling something out. What did both x squared and 9x have in common? They had an x in common. So same thing here. What do both of these have in common? R squared and 10r? They both have an r in common. So it's the same thing, it's just looking at a different way. R times what is r squared? R. R times what is 2r? 2. 2 times what is 20? 10. Right? And you can also look at this. What does 10r and 20 have in common? Oh, they both have a 10 in common. Right? And there's your answers. You're done. R plus 10 and R plus 2 does not matter on the order. I can put it in any order, R plus 2 and R plus 10, same thing. And we can go through and multiply it, show that you get 12R in the middle, right? And it all works. So some people like that, they look at this method and they look at over here and they say, well, this looks like a little bit less work or it looks a little bit neater. Either way is fine. Let me do one more using the box and then let you guys try a few. Okay, first going to set it up. Fill in my first and last into the first and last boxes. So I have my n squared and my 32. But the 12, I have two boxes. I only have one number, so I need to figure out what multiplies to 32 and what adds to 12. What are those two numbers? 8 and 4. So I know I got an 8n and a 4n in either order. Doesn't matter which order you put those in. And then I can start doing the factoring. So what does n squared and 8n have in common? They both have an n. Right? What does n squared and 4n have in common? N. And no surprise, n times n equals n squared. So you always have a check built into this. N times what is 8n? 8. Yeah. And so happens, what comes out of 8 and 32? They both have an 8 in common. 8 times what is 32? 4. And then also n times 4 equals 4n. And it all checks out. So there are your two binomials. N plus 4, n plus 8. So I've shown you two methods. Okay, one is basically this method in reverse. Right, we went backwards. And one is the box in reverse. But both of them are just what you already know, just in the reverse order. So if you ever get confused on, I'm not sure how to do this, go back, just write out two binomials, multiply them, and then ask yourself, how would you do that backwards and reverse? And you can get two different types of methods. So go ahead and try 9 and 10 using either methods, or do one apiece. Or if you know you like the box method better, just do the box method for both. Eventually, you're going to want to get to the left-hand side and not use the box for other reasons in Algebra 2. But that's down the road. For now, you can really use any method for the rest of this class, and you'll be safe. But eventually, not going to need boxes for, think of them as training wheels. Good for now. We'll take them off later, though, when you're ready. All right, so give 9 and 10 a try. Show all the work. Even if you think you know a shortcut and you can do it fast without showing any work, please do not do that. These are the easiest problems. We're going to get to harder problems later. that require all these steps, and when we get to them, you're not going to have a clue how to do it because you didn't practice on the easy problems using all the steps. You took shortcuts, and it will catch up with you later, I promise. So take the time, show all the work for all of them, so that when we get to stuff that's either medium difficulty or really hard, you're not going to be sitting there saying, oh, I don't know because I took shortcuts when I was doing the easy stuff and I have no clue how to do it now. Definitely show all the work from the very beginning, because there are some shortcuts which you might be able to spot, but it's not worth it. Okay? So take a look at the last two. On the first one, we'll have p squared. We'll have the minus 2, but we need to find two numbers that multiply to negative 2 and add to negative 1. So what are those two numbers? What do we get? So we got negative 2 and positive 1. Those multiply to negative 2 and they add to negative 1. So you got to be maybe a little more cautious when you have negatives involved, because it depends where you put the negative will be correct or incorrect. If you put the negative on the 1, that would be 2 minus 1, which is positive 1, not negative 1. So there are details involved here. We got to be careful. So we got minus 2p and plus p. Okay. And now if I want to factor out, right, I want to take something out that is in both of those. I can take out a p. That's going to be, it's a little bigger, p minus 2. Now you notice that this is already a p minus 2, but we still need to write it in the correct way like we did up here. So I'm just going to take out a 1, which really doesn't change anything because 1 times anything is that anything. So that's how you can get around when it's already the same thing, right? Remember your goal, you're always going to see these come out to be the same. If they don't come out the same, something is wrong. So we have p minus 2 as one of them. And we have p plus 1 as the other binomial. And let me do number 10. I'll use using the box, so you can get good at either method or both methods. So we'll have x squared. We'll have positive 14. We need two numbers that multiply to 14 and add to negative 9. Okay, so what two numbers did you get there? Add to 14, multiply to 14, add to negative 9. Negative 2 and negative 7 do work. So we get negative 7 and negative 2. And then we need to factor out. What can factor out from x squared and x? What do they have in common? They both have a x. And then you can say x times what is x squared? X times what is negative 7x? Negative 7. Negative 7 times what is positive 14? You get negative 2. And there's your two answers. Make sure you do write them as the binomial form. Don't just leave it as the box and say you're done. Rewrite it one more time like this. So remember, we're going in reverse direction. Before, this was the question, and this was the answer. Now we're going the other direction. This is the question. The binomials are answers. So the top of the page, those problems are the same as the bottom of the page. They're just in reverse directions. Okay, so I'm going to have you guys start the homework, show all the work, okay, and we'll go over the back tomorrow.